Alright, so let's talk about the domain of square roots and fractions. So the problem you're going to see is find the domain of whatever. So, especially for this first test, what you really need to be aware of is domains of, I guess not really square roots, more even roots. And what I mean by that is you're going to have an even number right there. So square root, a fourth root, an eighth root, and so forth, and then fractions. And whenever you're looking for domains, you actually want to do it in this order. The first thing you ask, does this function have an even root or square root? And then after you figure that out, then does it have a fraction? If you have an even root, okay, you're going to set the inside greater than or equal to 0 and solve for x. For fractions, the bottom or denominator of a fraction cannot equal 0. Okay? And then once again, solve for x. Solve for x. Okay. So let's do a couple of easy examples and then we'll combine it into one. So our first example. Say we have y is equal to the square root of x plus 4. Okay? What we're going to do is set that inside greater than or equal to 0. I have x plus 4 greater than or equal to 0. And so x is greater than or equal to negative 4. Now, you're probably going to want it in interval notation, so let's look on a number line. Put this on a number line. Out to here is negative infinity. Over here is positive infinity. Here's our negative 4. Our x is bigger than, greater than, negative 4. And it's greater than or equal to. If you have a greater than or equal to, or a less than or equal to, you will always put brackets. If it's a strictly less than or strictly greater than, you're going to use parentheses. So negative 4 is bigger, so all of this is gone. And we're going from negative 4 all the way to infinity. So I have negative 4 to infinity. So our domain, negative 4. Let's talk about a fraction. Say we have something like this. Y is equal to x plus 3 divided by x squared minus 9. Now here's why I wanted to put this one up. What some people are going to do, whenever they factor this bottom, that's going to be x plus 3 over x plus 3 times x minus 3. A lot of people are going to cancel out that x plus 3. Yes, in that sense it does going to cancel out, but when dealing with domain, and domain only, you actually in fractions, unless there's an even root on the top, I want you to completely ignore the top. You need the entire bottom cannot be 0. What's happening when these cross out, you actually have what's called, technically it's called a removable discontinuity, or in other words, it's just called a hole. All that it is. Alright? So with this, we want to set the entire bottom. And the entire bottom cannot equal 0. So, if I have x squared minus 9 cannot equal 0, x squared cannot equal 9, therefore x cannot equal plus and minus 3. Remember, whenever you take the square root of something, you need to account for both plus and minus, because negative 3 squared is also 9. So once again, let's put this on our number line. Here is negative 3. Here's 3. From negative infinities out that way, positive infinities over here. Now, with fractions, if you don't have an even root, everywhere is all good, except for at negative 3 and 3. So I'm going to be coming from here, and I'll be approaching, but it'll never be negative 3. Then I'm going to go from negative 3 to positive 3. Then I'm going to go from positive 3 to infinity. From negative infinity to negative 3, negative 3 to 3, and then 3 to infinity. So how you want to write this in interval notation is going to be negative infinity to negative 3. And then you need to have this union symbol, union with negative 3 to 3, union with 3 to 2. Let's do one more. The last one I want to do is I want to incorporate both even roots and fractions. Okay? So, for this last one, I want to do y is equal to, say, x plus 2 over the square root of x plus 4. And I want to find the domain of this function. The first thing I ask, is there an even root? You always do that first. I'm not going to worry about the fraction just yet. Just ask myself, is there an even root? In this case, yes, I have the square root of x plus 4. And even roots tell us we're going to set the inside greater than or equal to 0, just like we did previously. So we have x plus 4 greater than or equal to 0. X is greater than or equal to negative 4. Just like last time, we have our number line, negative 4, because it's greater than or equal to, I have a bracket, infinity, negative infinity, all this is gone. Wonderful. But now we got to ask ourselves, is there a fraction? Yes, there is a fraction. And the fraction tells us that the bottom cannot equal 0. So what I'm going to do is x plus 4 cannot equal 0. So x cannot equal negative 4. Since negative 4 is not included, you turn this bracket into a parenthesis. So this domain is simply just from negative 4